Hello everyone and welcome to today's new stream. I'm Jade. I'm thrilled to discuss Precast together and cast issue together with all of you during today's broadcast. Today we will be zeroing in on a critical topic, in bridge consideration, the cooperation between precast beams and cast-in-place beams. Whether you are new to the field or a second professional, I'm confident this session will give you clear and more comprehensive insights into both types of structural members. Feel free to drop your questions in the chat. Throughout the stream, we will be answering them. Now, let's dive right into today's content. First, let me provide an overview of our company. Our company, Shandong Boyoun Heavy Industry Company, was founded in 2006 and focuses on the fabrication, marketing on-site technical services of steel formwork for bridge, viaduct, tunnel engineering. The headquarters and main factory are located in Binzhou City of Shandong, China, with international department located in Beijing. The annual output is more than 75,000 tons. Boyoun has been qualified by an SOQM system since its foundation. More than 30 patents have been approved each year. Boyoun has served over 1,200 infrastructure projects, mainly for high-speed rail, expressway, railway, highway, and other large-scale infrastructure projects, with experienced formwork solution, cooperate with giant state-owned enterprises and well-known overseas construction groups. Over the years, we have gained extensive experience and enterprise and built a strong reputation in the industry. We are dedicated to providing our customers with high-quality products and, more importantly, with excellent service and technical innovation. First, let's clarify the definition of pressed beams and cast-in-place beams. Precast beams, simply put, they are beam units manufactured in advance at factories or dedicated casting yards. They are produced in specialized techniques using standardized process according to design specification. After production, they are transported to the consideration site for installation. In practice, casting beams with precisely calibrated foundations ensure dimensional accuracy and stability during corporeal. Cast-in-place beams, these are formed by installing formwork, reinforcing steel and parallel. Considered directly at the final bridge location. Consideration strictly follows the pour immediately after formwork inclusion principle to ensure structural integrity. After understanding the definitions of both, let's make an initial comparison of their advantages and disadvantages. First, let's talk about the advantages of precast beams: high construction efficiency, since precast beams are manufactured in advance in factories. Their production can be carried out similar with the construction of substructures such as bridge foundation, which greatly shortens the overall consideration period of the bridge. For example, where the foundation is still under consideration, precast beams are already being produced in the factory. Once the foundation is complete, the precast beams can be quickly hoisted in place. In practical engineering, for a simply sport beam bridge project on an expressway using precast beams and shorten the construction period by about 30% compared with cast-in-place beams. Easy quality control. Precast beams are produced in specialized factories with a stable construction environment, professional equipment, and skilled technicians. Links such as considerate promoting vibration and cooling can be strictly controlled, resulting in relatively more stable quality. For instance, the qualified rate of considerate strength for precast beams can usually reach over 9,008%, while that of cast-in-place beams may be slightly lower due to on-site factors. Little impact on the consideration side. The production of precast beams doesn't take place at consideration site, which reduces on-site operations, such as material stretching and considerate mixing, and lowers the interference to the surrounding environment of the consideration site. For example, noise and dust pollution will be significantly reduced in bridge consideration near recreational areas. The use of precast beams can efficiently reduce resistance covenants. However, precast beams also have some disadvantages. High transportation cost. Precast beams are large in warm and wide, requiring special large transport equipment during the transportation. Moreover, there are certain restrictions on the transportation results, especially in remote areas or areas with poor road conditions. The transportation difficulty and cost will increase. For example, the transportation cost of a 30-meter long precast beam alone may reach 12,000 yuan. High installation requirements. The hosting of precast beams requires large lifting equipment, and the precision requirement of hosting is very high. Once the installation dimension is too large, it may affect the structural safety of the interbridge. In electrical hosting, precision instruments such as total stations are used for hosting to ensure that the installation limitations is controlled within the large allowed by the specifications, and general the later dimension does not exceed 5 millimeters. For flexible precast beams are produced according to standard stands. For some bridges with complex shapes and special size, precast beams are difficult to meet the requirements. For example, for some bridges with Current changes the abilities of precast beam is obviously insistent. Let's look at the advantages of cast-in-place beams. Strong flexibility. Cast-in-place beams are poured on-site and can be constructed according to the specific design shape and size of the bridge. They are especially suitable for some special shaped and complex structural bridges such as current bridges and variable width bridges. In actual consideration, cast-in-place beams can be easily handle bridges with large spec changes, good overall performance. The steel bar connection and contract producing in cast-in-place beams carried out continuously, so the beam body is more closely connected with other structures of the bridge, with stronger integrity and relatively better performance in bridge consideration. In earthquake-prone areas, the advantages of cast-in-place beams are more prominent. No need for large transport equipment. Cast-in-place beams don't require long-distance transportation, avoiding various problems in the transportation process of precast beams, especially in mountain areas and other areas with inconvenient transportation. They can save a lot of transportation costs and time. However, the disadvantages of cast-in-place beams are also obvious. Long construction period. The inter-production process of cast-in-place beam is carried out on-site from formwork, erection, steel bar building to considerate pouring and carrying. Each link needs to be carried out to screen and can't be carried out in parallel with the construction of some structures, resulting in a relatively long construction period. Taking a medium bridges as an example, the construction period of cast-in-place beams may be 2 or 3 months longer than that of precast beams. Quality greatly affected by the environment. The environment of the construction site changes greatly. Factors such as weather, temperature, and humidity will affect the quality of considerate area and carrier. In case of rainy days, it is necessary to build rain shelters in high temperatures. Carrier measures should be taken in severe cold weather. Height preservation and carrying should be carried out, otherwise it will have an adverse impact on the quality of the beam body. High requirements for the construction site. Cast-in-place beam requires a lot of site operation, needing significant space for material stacking and formwork electrician. Moreover, on-site operations such as considerate finishing and regulation will produce mold, dust, and other pollution, which have a greater impact on the surrounding environment. This impact is more obvious in bridge construction in urban central areas. Having understood the advantages and disadvantages, let's now take a look at their production process. First, the production process of precast beams mainly includes the following steps, and These steps have strict operational specifications in actual consideration. Step 1. Preparation work in the precast factory. First, clean the precast sheet and install the precast formwork. The size and shape of the formwork must be made in strict accordance with the design drawings. After the formwork installation is completed, trial assembly and verification will be carried out to ensure that the area is within the allowable range. At the same time, the pedestal will be plugged and oiled to facilitate later formwork removal. Step 2. Reformation beginning. According to the design requirements, bend the steel inclination of the beam body in the mold to ensure that the specification, quantity, and spacing of steel bars meet the standards. The reinforcement building will be fixed with a position form to ensure the accurate position of the steel bars. In particular, the protective layer thickness of the stress steel bars will be controlled by using special consider blocks. Step 3. Considerate pouring. Pour the mixed considerate into the mold and they use vibration equipment to vibrate to make it descend, avoiding defects such as honeycombing and putting. During vibration and the pressing of insertion quickly and pulling out slowly will be followed to ensure that each part is vibrated in place and the vibration time is generally controlled within 20 and 30 seconds. Step 2. Curing. After the considerate pouring is completed, carry out covering and hysterizing curing to ensure that the considerate reaches the design strength within the specified time. The during made will be selected according to the weather conditions. In summer, breaking and covering coating is usually adopted, while in winter steam curing will be used during the curing period. The humidity and temperature of the considerate will be minute regarding. Step 5. Formwork removal and strong. When the considerate strength reaches the design requirements, remove the mold. Inspect the precast beam and after passing the installation, strong in the precast yard waiting for transportation and installation. When strawing, they will be stripped in an orderly manner according to the number and the scans will be placed under the beam body to avoid uneven stress on the beam body. The production process of cast-in-place beams is different and there are on-site operation pays more attention to cooperation with the surrounding environment. Step 1. Formwork electrician. According to the design requirements, set up the scaffold and the consideration position of the bridge. The scaffold must have sufficient strength and stability, and a preloading test will be carried out to check its bearing capacity. The preloading weight is usually 1.2 times and the weight of the beam body. Then install the formwork on the scaffold. The formwork must be firm and tight to prevent growth, leakage, and the joints of the formwork will be sealed with staining strips. Step 2. Reinforcement beginning. build the steel beams of the beam body in the formwork, including strings and steel bars, and set the protective layer of the steel bars at the same time. Different from precast beam, the steel beams in cast-in-place beams may be connected with the steel beams or other structures of the bridge to form an international stress system. Step 3. Considerate pouring. Transport the considerate from the considerate mixing plant to the seat. Pouring the considerate into the formwork by pulling on other methods and vibrate it to make it descend. The considerate pouring will be carried out in levels, and the thickness of each layer is generally not more than 30 centimeter to ensure the vibration quality. During the pouring process, the slab of the contract will be initiated in real time. Step 2. Carrying like precast beams. Cast-in-place beams also need to cool after pouring, usually by covering and sprinkling water or spraying carrying agent. During the carrying period, the special professional will be arranged to ensure that the surface of the beam body remains most of the time stem-free. 5. Formwork and scaffold remove. When the considerate strings reach the design requirements, remove the formwork and scaffold in the specified order, generally following the precept of removing the first spotted ones last and the later spotted one first to avoid damage to the beam body. The different advantages and disadvantages determines that precast beams and cast-in-place beams have their own able application, and there is thinness have clear saturation. Considered in processing engineering, precast beam are mainly applicable to the following areas. Firstly, large scale and the standardized bridge consideration projects such as simply spotted beam bridges in expressway and railways. These bridges have uniform beamforms which are suitable for mass production and can give full play to the advantage of high consideration efficiency of precast beams. Secondly, projects with tight requirements on the consideration period, because the precast beam can be constructed in particle which can effectively shorten the consideration period. For example, some bridge projects that need to be opened to terrific as soon as possible often use precast beams in the reconstruction projects or some urban expressways. Precast beams are preferred to reduce the impact on traffic. Thirdly, in addition, where the construction site considerations are limited, such as narrow consideration size and sensitive surrounding environments which are not suitable for large-scale on-site operation. At this time, the use of precast beams can reduce entrance to the site. In bridge consideration in most spots, precast beams are mostly used to protect the environment. Cast-in-place beams are more suitable for these scenarios. Firstly, bridges with complex shapes and special such as the beam parts of continuation rigid from bridges and arch bridges. The beam destination and shape changes of this bridge are large, and precast beams are difficult to meet the requirements. While cast-in-place beam can be better adapted to them. Secondly, bridges with large splitting cavity. The beam bodies of some basement bridges need a better integrity and coordination, and the continuous pouring of cast-in-place beams can meet this requirement. For example, bridges with a span of more than 100 meters mostly adopt to the construction method of cast-in-place beams. Thirdly, areas with inclement transportation conditions, if the bridge construction seat is removed and the transportation of precast beams is difficult and costly, the use of cast-in-place beams will be more actually feasible. Over the years, with our high-quality products and professional service, we have won high recognition and praise from numerous customers. From the project construction to the after-sales service, we have made our customers feel comfortably at ease. We have established long-term and stable relationships with many customers, such as CRCC, Devil, Hyundai, ITD, IGM. This is not only our honey but also the driving focus of our coordination projects. Besides the precast together formwork and cast-issued formwork, Boyoun products also include centimeter foam traveler and underring foam traveler, segment box gather formwork, pair formwork, tunnel lining tutorials. Some typical overseas projects have been delivered, such as the China-Malaysia Friendship Bridge in the Maldives and the Malaysia East Coast Railway, Malaysia MRT2 and LRT3, and Singapore North-South Carrier Project. Our bridge formwork has many significant advantages such as high precision, high stability, and constructiveness. Whether you are facing the bridge consideration project in complex terrain or have special requirements for projects, we can provide you with tailor-made solutions to meet the needs of various bridge consideration projects. If you have relevant business needs, please feel free to contact us at any time. We look forward to working with you. Welcome to stay tuned to our new broadcast.